So, again, I'm sorry, we're talking about exponents, and we need this in this chapter because, again, we're dealing with fractions that also have maybe variables with exponents. So just as a review, right? A review, when we multiply, 5 to the third means 3 factors of 5, right? And as a value, it's 125. But this 5 to the third is representing 3 factors of 5. If I multiply 5 to the third times 5 to the third, now I'm multiplying 3 factors of 5, which is 5 times 5 times 5, times another 3 factors of 5. So in total, I have 6 factors of 5, which I can write as 5 to the 6th power. So it does appear that when I'm multiplying and the bases are like, I can total the exponents. I don't want to say necessarily add, but it's really coming up with a total number of factors. So there is this rule, right? If we have like bases, alright, and here my base is a. If I have a to the 4th times a to the 3rd, it's talking about 4 factors of a times another 3 factors. So it's a total of 7 factors, and so I can write it as a to the 7th. And really think of it as a to the 4 plus 3. Because again, I'm multiplying and exponent already is multiplication. So it's just kind of continuing on more multiplications. So in words, the multiply powers with the same base add their exponents. So algebraically, and this is again, this is where we advance our thinking so that we can think in general terms. A to the m times a to the n, since they're like bases of a, we can make it a to the m plus n. No matter what m and n are, we can add those values together to get a total. So for 4's here, we have 4 to the 3rd times 4 to the 2nd, since they're like bases. What happens if they're not like bases? 2 to the 2nd times 3 to the 2nd. Well, I can't make that anything other than 2 factors of 2 and 2 factors of 3. They wouldn't turn into 4 factors of 6 or anything like that. But interestingly enough, you can rearrange this to be 2 times 3 times 2 times 3, commutative property, associative property, and then multiplying 2 to the 2nd. If the exponents are the same, but the bases are different, and the product of that would be the product to that power, because it would be the same number of those 2 times 3's. So it would be 2 2's and 2 3's, or 2 6's. So it would be 6 to the 2nd power. That's an interesting turn of events there. And the inverse, or the opposite of that, would be the quotients of powers. So instead of multiplying, if we're dividing like we are here over here, and they have the same base, again, this is like 5 5's divided by 3 5's. We know that 3 of the 5 are going to cancel. So these 3 will cancel with 3 of these 5, and you can almost think of it as subtracting to get 5 to the 2nd. Come on there, thing. If I canceled out 1, 2, 3, I'd be left with 5 to the 2nd, you see there. So if you have m to the a to the m over a to the n, like bases of a, you can subtract to get to the a to the m minus n. As long as, now it says as long as a does not equal to 0, because again, you cannot divide by 0. So using this and coupling with our other notes here, I see a GCF of 3 in here. 24 is 3 times 8. 15 is 3 times 5. I can cancel out the 3. Alright, so I can cancel out, let me do purple. cancel out the 3 out of the top and bottom. And then I can subtract or cancel out these two w's with two of these. Going to leave me with two w's up here. Z to the 9th, I can write them out and cancel out, but these three z's are going to cancel out with these, and this is z to the 9 minus 3, or z to the 6th. And whatever's left, this mess in the top, 8w squared z to the 6th, and in the bottom 5, and that's it. Alright, I'm asked to, again, you got to think about what are you being asked to do. You're asked to multiply those together. So this is 4 times a times b times 5 times a squared times b to the 3rd. Multiplying those, you want to think about maybe rearranging the factors. 4 times 5 is 20. A times a to the 2nd is a to the 1 plus 2, or a to the 3rd. And b is b to the 1st times b to the 3rd is b to the 4th. We're going to do a few more examples of these in class. Thank you.